Сейчас я бы хотел, чтобы мы уже перешли непосредственно к докладам, ради чего вы все здесь собрались. And let me introduce David. He is from Oracle and talk you about Java Enterprise Edition. Okay, David, let's start.
Is it okay? Yeah. So, good morning, everyone. It's a great pleasure to be here this morning. I mean, seeing such a crowd on a Saturday morning. It really shows that there is a huge and very motivated community in this country, so I'm really happy to be here. So, my name is David Delabassee. I work at Oracle in the Cloud Application Foundation team. So, within our team, we basically deal with Java EE, Glassfish, WebLogic, and related projects. So, today we'll talk about Java EE. I will do some kind of state of the union. So, basically, we'll look at Java EE, where we are coming from, where we are today, and also where we are going to, so give you some kind of glimpse at the future. I work at Oracle, so I assume that if you have already seen a presentation from one of my colleagues, you should have seen that slide. That's basically the standard disclaimer slide from Oracle that basically says that everything which I will talk about in terms of product features and roadmaps might change. So that's something that you have to keep in mind. Anyway, we can now really start. So Java EE, Java Enterprise Editions. So first of all, it's a good idea to set the stage, set the context before we talk about Java EE. So we have the Java platform. At the middle, we have Java EC, Java Standard Edition, the JDK. The Java EC is we often say that, okay, Java EC is for desktop. It's more than that, because obviously we are using Java EC on the server side as well. On the left side, we have a subset of Java EC. That's Java EMI, Java Micro Edition. So Java Micro Edition basically targets the development and deployment of applications for embedded device at large. So copy machine is a good example, a fax machine. Fax are still widely used today. You wouldn't believe that, but it's true. Any kind of controller, industrial controllers, heating system controller, and so on. So really where there is a huge space where it makes sense to embed Java, and that's what Java EMI is for. On the right side, it's Java EE, Java Enterprise Edition. So it's a superset of Java EC that aims at enterprise. So we have basically added capabilities which are required for enterprise applications. So that's the Java platform. Now, something else we have to keep in mind, when it comes to the evolution of Java, we have to keep in mind that everything is done within the GCP, the Java community process. So it's not just Oracle that decide how Java should evolve. And this is true for the complete platform, Java EC, Java EMI, and Java EE. If we look at the names we have within the GCP, well, we have big names such as IBM, Red Hat, SAP, Fujitsu, ARM, and so on. We also have representatives from the open source community. Apache Foundations, for example, the Eclipse Foundation are involved within the GCP. And there are also user groups. The London Java community, for example, is involved within the GCP. The Brazilian Soja Jug is also in there. So again, it's clearly not Oracle that decide alone where Java needs to go. It's really the community together that decide within the GCP what we should focus on for the next version of Java. Just one word, JSR, Java Specification Request. I guess that most of you know what it is. It's a specifications around something in Java. So I tend to use that term a lot. So just keep in mind when I say JSR, it's just a specification that has been defined through the GCP. So something is clear about Java. It's widely used today. I mean, we have some stat that says that there is roughly on the market 9 million developers that are developing in Java. Either Java EC, Java EE, Java EMI, it doesn't really matter at the end of the day. 9 million developers, so it's a lot. It's widely used. Today, if we talk about Java EE only, Java E6, we have 18 compliant Java E6 applications on the market. So that's a lot. You see some of those names, IBM, SAP, Red Hat, Oracle. So some big names, but we have also, I would say, smaller players such as Cosminexus, for example, or Tmaxsoft. Those players are also a Java EE application server. So Java E6 is really today now the standard for enterprise applications on top of Java. Java E6 was launched nearly 4 years ago in Devoxx, so in December 10 in 2009. So I would say it's quite old technology now. But if we look at the journey that Java E has to go through, Java E was basically started 15 years ago. So 15 years ago, at that time it was Sun decided that maybe the JDK as it is not enough for enterprise. So we need to add capabilities to develop enterprise applications. For example, transactionality, adding web services support, adding an easy way to talk to the database, adding capabilities to talk to backend system, and so on. So those kind of features. So over time, the platform grew. So G2E, it was called at that time, grew till G2E 1.4. So in G2E 1.4, we had a lot of capabilities. The platform was complete. We had web services, support, and so on. But it was so complete that it was also complex to master. I mean, it was difficult to write G2E 1.4 application. So in Java E5 in 2005, it was decided that maybe it would be a good idea to look at that and trying to solve that. How can we make the platform, the Java E platform, more easy to develop with? So in Java E5, there has been a big focus on ease of development. How can we do that? Well, for example, using annotations. So by using annotation, we'll put decoration in the code to specify what we, Java E developer, expect from the application server. So there is a shift of responsibilities between the developers and the application server. The developer has to do less. He has to focus more on the business logic, and the application server has to do more. It has to focus really on the dirty plumbings. So moving on, we see that in G2E 1.4 we had 20 specs, in E5 28 specs, and now today 32 specs. So the platform continued to grow. So in Java E6, it was decided that maybe we should do something about that. The platform cannot continue to grow forever. So in Java E6, it was decided to solve that. And in Java E6, we have introduced the notion of profile. A profile is basically a way to define, in a standard way, a subset of the platform. So today we have one profile, that's the web profile. As the name implies, it aims the development of modern web applications. And obviously, we still have the full Java E platform, which includes everything else. So today, 2013, Java E7. Now, before looking at Java E7 in more details, I just want to spend 1 minute on what is driving the evolution of Java E. So we have to keep in mind, this is happening within the GCP, but how the expert group working on the different Java E specifications decide where it needs to go. Well, Java E has to follow the evolution of the different standards. So we embed web services, so we have to follow the evolution of those standards. There is a new emerging standard that is widely adopted. WebSocket is a good example. We have to adopt it. So Java E has to adopt those standards and follow their evolution. Obviously, the idea is not to adopt all the standards. I mean, we are really focusing on the standard that makes sense and the standards that are widely adopted. Java E needs to follow the market evolution. So sometimes we get strong signals from the market that something is not right within Java E. For example, the fact that the platform is too big. That was kind of message we got from the market. So that's why we have defined profiles. Another signal we got from the market is that Java, at that time it was G2E. G2E is nice, it has a lot of features, but it's difficult to master. So I want to look at something else, another alternative that maybe is not as complete, but it's easier to use. So that's why ease of development was tackled in Java E5 and 6 and so on. Some signal we get from the market, for example, REST. REST is widely used today. That was not true 10 years ago. But the market told us, okay, we want to do REST. So Java E has to follow that as well. And finally, the last factor that is driving the evolution of Java EE is Java SE itself. I mean, we are adding capabilities within Java SE, such as generics, annotation, auto-closable interface, Lambda in Java SE 8, and so on. So it's a good idea to look at how we can leverage those capabilities that are provided by Java SE, leverage them within Java EE itself. So Java EE 7, the current version, was launched mid-June. So at that time we did an online launch. We had something like 4 hours of online webcast, online chat. We had, I think, 15,000 people attending that event, so it was really a hit. Something worth to mention is that it's also the first Java release that is being done under the Oracle umbrella. Java EE 6 was released by Sun Microsystems. This is now Oracle is the spec lead of Java EE. Oracle is the steward of Java. This is the first Java release under that. So it's something worth to mention. So there is a strong momentum. Even though we are just a few months behind us, there is a strong momentum around Java EE 7. So some specs. So Java EE 7, 14 GSR, 16 specs lead, nearly 200 experts working in a different expert group, coming from 32 companies. We have also experts, individual experts, so you can contribute within the GCP as an individual. You don't necessarily have to be involved through your company. 22 active projects, so all the reference implementation were developed in an open source way. So since the early days, you could have access to the source code of those reference implementation. Glassfish 4 is the Java EE 7 reference implementation. Since the beginning, you could download the early builds of Glassfish 4 to see what Java EE 7 would be. This was done really in an open and transparent way. Something worth to mention as well is Adopt.GSR. It's a program we have launched at that time, and the idea was really to ask mainly the Java user group to help us to shape the technology. So what we have said to different user groups, okay, we have different technology within Java EE, take them, stress test them, and give us feedback. For example, in Belgium, the BJUG has used Tyrus, so the WebSocket reference implementation, and has really stressed it against, for example, the iOS WebSocket implementation. And they have raised, they have found issues. They have raised tickets, and we have solved those issues before Java EE 7 was finalized. Another statistics about Java EE 7 is the number of books. That's a slide I've done for Open World 3 weeks ago in San Francisco. So today we have 14 books around Java EE 7. It's really the first time that we have that many books at the launch of a Java EE version. Now I have to admit, I have to use some tricks to get those numbers. So there are 3 books in German, but they are on Java EE 7, so they do count. And the 3 last books are not yet published. This one will be published, I believe, in 1 or 2 weeks, and those 2 last ones will be published by the end of the year. But still, we have a lot of books on Java EE 7. So that's really a metric that shows us that there is strong demand and strong momentum around the platform. Because clearly, book publisher doesn't take any risk. They won't publish books if there won't be any demand. So, what are the themes of Java EE 7? There are 3 big themes. HTML5, meeting enterprise demands, because at the end of the day, Java EE is a platform for enterprise applications. And developer productivity. So that's basically ease of development. Continue to simplify the platform. So HTML5, what we have done on that front, we have added 2 APIs, the WebSocket API and the JSON API. So WebSocket provide low latency, full duplex bidirectional protocols, and JSON, a lightweight interchange data format to exchange basically data between applications. We have also revised the servlet API so that it's more, I would say, HTML5 friendly. And finally, we have also improved the REST API. So I will give you some details on that later. Developer productivity, so continue to use annotations, so continue to improve the use annotation so that it's easier to develop applications with Java E7. The idea is that really the developer has to write less and less boilerplate code. It's not your job to write boilerplate code. It's the application server provider that needs to handle that issue. And finally, on the enterprise front, we have added 2 new APIs. The batch API to do batch job processing. So that's something which is new in Java EE, and the concurrency APIs. We have also worked on simplifying some existing APIs, some widely used API. So, WebSocket. So, first, what is WebSocket? So, WebSocket is a full duplex communication protocol that is being achieved over one single TCP socket. Web friendly in the sense that, for example, the negotiation for WebSocket communication is done over HTTP. It's full duplex, meaning that the two sides of the communication can talk at the same time. One side doesn't have to wait that the other side is done to start sending. WebSocket is a standard, so it's being defined within the Internet Engineering Task Force. And if you look at the W3C HTML5 standard, it also mandates WebSocket. So meaning that if you take any any HTML5 browser, it has by default WebSocket support. And not only that, it also provides a JavaScript API. So if you take any HTML5 browser, you can be sure that it has WebSocket support and it has the corresponding JavaScript API. So what we are using WebSocket for? Well, to do highly interactive sites, for example, or to let the backend side, so the server, push information to the client side, those kind of things. So GSR 356, Java API for WebSocket, is a GSR that defines a Java API for doing WebSocket in a standard way in Java. There are two variants of the API, client-side API and a backend-side API. There are two ways to use this API, using annotation and a more traditional programmatic approach. Obviously, the second one is a little bit more, I would say, verbose. It's not that complex to use, but the annotation approach is very easy to use. And that's what we will see in this. This is what we are seeing in this slide. So this is a basic chat server application. So what we have in black is basically a simple POJO, so a plain old Java object. We are using the first annotation, so the @server endpoint annotation to specify to the application server that this code should be turned in a WebSocket endpoint. And it will be exposed at the chat URI that we specify in parameters here. Now, the only thing we have to do is to react on event. So the first event we will react upon is whenever there is a new connection. That's what the onOpen annotation is for. Whenever there is a new connection, we just take the remote endpoint and we add it to a list. And we do the opposite whenever someone is dropping the connection. So whenever a connection is being dropped, we just take the endpoint that has disconnected and remove it from the list. And finally, the last event we will handle is whenever there is a new message coming on the connection. What we do in this case, we just take the payload that is being sent, that we get here, and we send it back to all the endpoints that are connected. So you see, we couldn't do more simple than that. It's very easy to understand, and you can use that using so that is the backend side. You can use on the client side, for example, an HTML5 JavaScript API that will work. Another API which has been added in Java 7 is the JSON API. So the full name is Java API for JSON processing. I guess that most of you know what JSON is, JavaScript Object Notation, so a lightweight data interchange format. And the nice thing about JSON, so first of all, it's widely used, but I think since last week, JSON is also a standard. So ECMA 404 is a standard for JSON. It's 5 pages long, so it's a very easy to understand standard. We often compare JSON to XML. So JSON is lightweight, XML is not lightweight. JSON is very basic. XML is way more powerful, but in most of the case, we don't use the power of XML, so why bother? we can use JSON, because in most of the cases, it really fills the bill. It fulfills the job. There are two variants of the API. A streaming API, which is highly efficient. It's a pool model. So it basically streams and it sends us event. It's similar to the Stack API we have on the XML side. And based on that API, we have an object model API, which is simpler to use, but it's not as efficient. So that's the price you have to pay. It's similar to the DOM API for XML. Now, something I have to mention, this API is really about parsing and generating JSON. It's not about binding JSON to a Java object. That's something which will come later. How it works? Well, we have a JSON object, so it's user with an array of 2 phone numbers. So if I want to get the first name of the user, this is the code I have at the bottom of the slide. I first need to get a parser. I need obviously to pass my payload to that parser, and then my parser will just send me event. So I just need to stream through that. So the first event I will reach is the start object event. The second event will be the key name. Next event is the value string. That's the event I'm interested in. So I can do a get string on that one to get the actual first name of the user. The other way around, so how can we generate this JSON object using Java code? It's exactly the same approach. Instead of a parser, we need a generator. And then we'll just use a Fluent API to describe the object. So it's an array, so I use the begin array method. I use the begin object to describe my first object. I describe my object, I close the object. I do that for the second object. I close the JSON array, and finally, I close the array, and then I use the close method to actually generate that JSON representation. So you see that it's easy to understand. Now, something I have to mention around those APIs, so WebSocket and JSON, it's not the first time we have the capabilities to do JSON and WebSocket in Java, but it's really the first time we have a standard way to do that in Java. Another API which is important when it comes to HTML5 is RESTful Web Services, JAX-RS. So JAX-RS 2 has been greatly revamped. We have added a lot of capabilities. So I clearly don't have the time to cover all the new features, so I will just spend a few minutes on one of them. That's the client API. So if you look at JSON, I mean JAX-RS 1.1, so it's basically a framework that allows you to easily define RESTful web services. So just by using a few annotations, you can turn a POJO and expose it as a RESTful endpoint. The problem was really on the back end, on the client side. On the client side, well, there was no API, so you had to do everything by yourself. So you had to construct the URL of your resources you want to reach by string manipulation. Then you had to do an HTTP URL connection, connect to that endpoint, handle the potential error you might get, and so on. So to solve that, most of the JAX-RS implementation came with their own client API. It was kind of funny because on the client side, the API was very easy to use, but on the client side, it was a desert. So that's why most of them brought their own client API. But the problem is that obviously they were not standard. So that's what we are solving in JAX-RS 2. There is now a standard JAX-RS client API. You see how it works? So if you are familiar with JAX-RS on the backend side, you will see that it's basically the same approach. So we first need to have a client instance that we get through this client builder. And then we just describe the web target we want to reach. You see that as on the backend side, we have access to templates. So in this case, the order ID will be resolved and passed as 10. We have access to the query parameters. We specify that it's an HTTP GET, so we can specify the verbs we want to use. And finally, we specify that we expect to get back a string type, sorry. So you see that, again, it's fairly easy to use, fairly easy to understand. Something else which has been added in JAX-RS 2 is asynchronous capabilities. So this is again the same client API, but this time we will use the async method. So you see that it's a very fluid API. We just add the async method to specify that this request should be invoked asynchronously. So what I get back is a future object that I will be able to use later on to know if my request has been processed, get the result, and so on. And optionally, I can also specify callbacks that will be invoked whenever the request is done or whenever something goes wrong. So WebSocket, JSON, JAX REST, RESTful Web Services, all are really focused on the HTML5 front, but it's not all. If we look at the Servlet API, it has been revised to be, I would say, HTML5 friendly as well. So in Servlet 2, we had synchronous capabilities. In Servlet 3, we have added asynchronous capabilities. And in 3.1, we are adding non-blocking IOS capabilities. So it basically allows you to scale more. Servlet 3.1 also supports HTTP protocol upgrade. So that's something which is specified in HTTP. It's basically a way to upgrade an HTTP protocol to something else. That's what we are using, for example, in WebSocket. So we start the WebSocket connection over HTTP, then we use this mechanism to upgrade it to a WebSocket connection, and so on. So clearly, the new features of Servlet 3.1 are maybe not the features you will use directly. They are more, I would say, infrastructure features that we have done within the platform. GSF 2.2, Java Server Faces, has also been improved to be more HTML5 friendly. So just to pick one example, GSF 2.2 let HTML5 attribute pass through. So that means that whenever the backend side sends an HTML5 attribute, GSF will not try to interpret it. It will let it pass through so that the browser can handle it directly. So that was some of the enhancement that has been done in Java 7 on the HTML5 front. And it's really important that we are doing that, because if you look at the market, I would say for web/rich UI technologies, if you look at, for example, Flash or Silverlight, all those technologies are kind of being killed in favor of HTML5. So the market is really going towards HTML5. So we have, Java EE has also to embrace HTML5. On the enterprise front, we have added two new APIs, the batch API and the concurrency APIs. So the first one, batch applications for the Java platform, GSR 352, was led by IBM. So if we look at our industry, I mean the IT industry, since the beginnings, we are using computers to do batch jobs. What is a batch jobs? Batch jobs. It's basically we take a lot of data, so bulk of data, and we process them. Most of the time it was done overnight. It was offline, so it's really non-interactive, bulk-oriented data processing. And that's something we have done since decades. But until now, if you wanted to do that in Java, there was no easy, well, you had different options. The first one, you could buy a solution from a vendor. That was one way to do batch processing. Or you could write your own solutions to do that. Or you could also write your own solution based on existing frameworks such as Spring Batch. And clearly that is the most widely used approach today. But the problem with those approaches is that they are not standard-based. So this is being solved with this GSR led by IBM, and I think we can agree that IBM has a long history within that space. But Spring Source was also heavily involved in that specification. So if you are familiar today with Spring Batch, you will see that it's highly influenced by Spring Batch. And Pivotal has said that Spring Batch will be compliant to that specification over time. So it supports different type of batch execution, sequential, parallel. You can define flows and so on. Two processing style. The one you will use the most is the chunked. So chunked is basically data processing. So you read something, you do some processing, and you write the output. But in some cases, you also need to perform operations which are not tied to data, so specific tasks. So for example, at the end of a batch jobs, you need to take the result, sign them, and put them in a data warehouse. This is not tied to any specific data. This is really a task. So for that, we are using batchlet. So some of the concept. We have steps. A step is an independent sequential phase of a job. A steps is made of a reader, a processor, and a writer. So this is for chunked steps. So steps which are tied to data. And then we have a job. A job is made of different steps. A job needs to have at least one steps. A job without the steps doesn't make any sense. And then we have a job runtime with a specific repository. The specification doesn't say how the repository should be handled. I mean, it could be a database, it could be a file system. It's not really an issue. And finally, we have a job operator. It's really the interface towards the jobs. So that's basically how you will start your jobs, how you will get metrics on your jobs, how you will restart jobs, because by definition, jobs can fail, and so on. So the job operator is really an API. It's not an interface. But obviously, you can build interface on top of that. So GSR 352 defines two things. A Java API that you will use to write your steps. And it also defines the GSL, the job specification language, which is used to assemble the different steps to form a job. And if you have done your job correctly, the idea is that you will easily be able to reuse your different steps to create different jobs. So GSL, so the jobs itself are defined using that specific XML language. So it has a lot of capabilities, such as inheritance of jobs. You can obviously define the steps, but you can also define flows. You can also define within GSL what needs to be done whenever, for example, one of the steps raises an exception. Those kind of things. So it's really powerful. So this is an example of some GSL. So in this case, this is a chunked definition, so a steps that will work on data. And in this case, we are defining the reader, the processor, and the writer. And what I will have to do as a Java developer, I will have to implement this reader using the GSR 352 API. So for example, the reader, I could read the data using GPA or using GMS, it doesn't really matter. I will process the data, and finally I will write the result. And in this case, I'm using Java Mail to send the result. And you might see that, this is a chunk, so we are working data, and there is an item count of 3. So it's basically, what we are specifying here is that we want to read, do the processing 3 times, and then we want to write the result, and maybe do some transaction demarcation there. Another example of steps, in this case, we have the GSL that define a batchlet, so a task-oriented steps, and it's called my file transfer. And what I'm doing here, I'm using the GSR 352 API to specify what needs to be done within that specific steps. So this is basically the GSR 352, so the batch API. There are a lot of other features. So error handlings, for example, or lifecycle. You have interceptor that you can use. So basically, you have hooks that you can intervene anywhere within the job execution, around the steps, around the reader, the writer, the processor, before, after, and so on. So it's really a powerful API. Another API which has been added is GSR 236, I believe. Concurrency utilities for Java EE. So until now, if you wanted to write concurrent, if you wanted to get concurrent behavior within Java EE, you had different approach. One of them, it was more patterns, is for example using GMS. So you send a message to a GMS queue, and there are different MDB that when they get that message, fires new task. That's one way to do it. So there are a different approach, but the only thing that you couldn't do is leverage the capabilities we have in Java EC. So in Java EC, we have GSR 166, the Java util concurrent package. You can't use it from Java EE. Why? Well, if you look at Java EE, it's basically, so you have your application server, it's a container, it's a managed environment, and you deploy within that managed environment your Java EE components, so your servlet, your EGB, and so on. And by doing that, the container provides you services, such as transaction management, security, etc., etc. But there are some contracts you need to follow. And one of the contracts is that you cannot span new thread from your components. Why? Well, if you do that, we are in a managed environment, so if you span new threads from, let's say, a servlet, those threads will not be managed by the application server. So if you do that, maybe it will work, but you can expect to have some issue at some point in time. Servlet, I won't say it's okay, but it should work, but within EGB, you can be sure that, well, you are going straight to a wall. That's what we are solving with this GSR. So this GSR provides asynchronous capabilities to Java EE applications by leveraging the Java util concurrent package we have in Java EC. So we can use all those constructions in a safe way in a managed environment. It provides 4 types of managed objects: managed executor services, the managed scheduler executor services, and the managed thread factory. If you are familiar with the Java util concurrent package, you will recognize the 3 first one. It's basically the same executor services, but in this case they are managed. So in Java EC we have an executor services, in Java EE we have a managed executor services, and so on. And finally, the last object is used to do context propagation. So if you span a new thread from a servlet, it might be useful that the servlet has visibility to the context, the Java EE context, I mean, to get, for example, the username of the user, those kind of things. So how it works? Well, it's easy. First thing you need to do, you need to have an instance of an executor services. So you can look it using GNDI, or you can use CDI. Then, as a developer, you will have to write the code that needs to be concurrent. And for that, you will use either the runnable interface or the callable interface if you want to return some data. And finally, you just submit that to the executor services. And the executor services will have the dirty jobs of scheduling the different tasks to the different threads, managing the pool, handling the synchronization, and so on. This is an example. So in this case, it's a servlet. It uses a managed executor services called batch executor. Here, I define as an inner class my task, which implement the runnable interface. So this code is pure Java EC code, and I need to implement the run method. That's basically where the action will happen. So that's what I want to have in a that's the code I want to be executed in a concurrent way. And here I just submit my task to my executor services. I get back a future object that I can use to check if my task has been completed, if it's still running, if an exception was raised, those kind of things. Obviously, I'm not limited to one single task. So here I'm doing exactly the same thing, except that I have 2 tasks, and those classes are using the callable interface. So those tasks can return results. And I'm doing exactly the same approach. So I'm submitting all my tasks to my executor services. And I get back a list of future objects that I can use, again, to check the status of the execution of those tasks, but also get the result back from those tasks. Another executor services we have is like the executor services, the first one, but it has the temporal notion. So in this case, we say that we want this task to start in 5 seconds, for example, and so on. So there are a lot more in this API, but I have to move on. So another API, GMS, Java Message Services. Who is using GMS today? So yeah, quite a few hands. So the current version of GMS, I mean, until Java 6, is GMS 1.1. GMS 1.1 was defined in 2001. It got a minor revision in 2003. So it basically means that it's a widely used API that is 10 years old. So it means several things. It means first that, well, this API, if it's still widely used today, it means that it works, that it was, I would say, nicely designed at the beginning, because if it was a bad API, no one would use it anymore. It also means that this API fills the need. I mean, GMS is used to talk to message queue from Java, so there is a clear need around that. But it also means that since this API has not evolved in the last 10 years, we are using today an API that has not been able to leverage any of the new features that has been put in the platform since 10 years. And when I say platform, it's really Java SE, but also Java EE. So we want to solve that with GMS2. So GMS2 has to be less verbose. We want to reduce boilerplate code, because in GMS 1.1 you have to write a lot of codes. And we also want to leverage new features of the platforms. So resource injection is one feature provided by Java EE. The auto-closable interface of Java SE 7 is another features that we want to use within GMS. So this is an example of how we can send a message, a string basically, in GMS 1.1. I have to apologize because the slide is not really, well, I had to use a small font, but it's really the minimum I mean, there is no way to simplify that. And even here, I'm not handling all the issue I might have. So anyway, the red line here is really where the action happens. So that's basically where we send the strings. But to reach that point, we have to do a lot of stuff. So we first need to create different intermediate objects. So we need a connection. From the connection, we need a session. From the session, we need a message producer. And here, I'm transforming basically my text payload in a text message format. So create a lot of intermediate objects. That's quite, well, that's not really useful. If you look at the signature of this method, we are using two parameters that doesn't really make sense in a Java EE context. So not only they are redundant, but they are misleading. But still, we have to use them. I mean, if we are not using the right signature, it won't work. So a lot of boilerplate code. Resources are expensive, so we need to make sure we close the resources when we don't use them. So that's something we have to do. All the exceptions that are being thrown are checked. So my code needs to make sure it handles them correctly, even though I'm not capable of really doing, I mean, when something is going wrong, well, I'm not sure what I have to do, but still I need to do it. And finally, I also need to create some specific resources. So you see that it's a lot of code that we have to write just to send one message. So I told you that GMS 1.1 is widely used. So we want to simplify how to use GMS, but we also have to keep in mind that a lot of people are using GMS 1.1 today. So we don't want to break that. So backward compatibility is something which is key. So what we have done in GMS2, well, we have two API now in GMS. We have the classic API, which is basically the old GMS 1.1 API, and we have the simplified API. So if we look at the connection create session signature, we have basically three signatures. Sorry, the connect create session method. We now have three signatures. The first one, the classic API, so the old create session with these two misleading parameters. We have a new one for Java SE. And finally, we have a new one for Java EE, connection create session without any arguments. So removing unused argument is one way to simplify an API. One easy way, I would say. What we can also do, well, we can use the auto-closable interface of Java SE 7. So whenever a new object, a new resources is created within a try-catch block, it will be automatically closed. So that means that the developer doesn't have to do that by himself. So how it works? Well, we just define our object within the try-catch blocks, and they will be automatically closed. So that's one way to simplify the code. Now there is a new object introduced in the simplified API, the GMX context, which basically combines the connection and the session. So using GMS context, we won't have to create all those intermediate objects that we had to do, as you saw in the first GMS 1.1 slide. So it's another way to simplify the API. Another way to simplify the API is that now we can send the text as it is today. We don't have to transform the text type to a text message format. It's another way of simplifying the API. So the clause is invoked automatically. And finally, another way is by using unchecked exception. So we are not forced to handle them. We can also use the default data source definition of Java 7, and you see that basically, so this slide basically performed what was done in the first GMS 1.1 slide. So we had something like, well, it says 13 lines, but it was, I think it was more, and we can reduce the code to just 1 line. So it's really a more simple to use API, but still, you can use the old one if you want to. So that was for enterprise demand, so batch, concurrency, and simplifying some API. Developer productivity, basically continuing to use more and more POJOs, so that you have to write less boilerplate code. You saw that for GMS. So one example that helps you to write simple code is beans validation 1.1. We can do validation on method parameters and method returns. So in this case, I'm doing on the top validation on the parameters of the method. So I have a placeholder method. I don't want the product to be null. And I want to have a quantity between 1 and 10. And finally, I also want to do validation against the customer using a custom validators. Second method, I have an appointment method. So whenever I call that method, I get an appointment back. I want to validate the return of that method just to make sure that all the appointments are in the future. It doesn't make sense to have an appointment in the past. GPA also be revised. One of the features which is quite nice in GPA 2.1, it can generate automatically the database artifacts. So that's something that simplified the lives of the developers. AGB 3.2. Well, I will maybe skip that one. Transaction. Until now, if you wanted to do transaction, you had to do that within the GB container. Now, using GTA 1.2, so in Java 7, you can have transaction demarcation within CDI managed beans. So you don't have to be within the GB container. So it's another way to simplify how you write your code. And there is way more capabilities that I don't have the time to talk about today. I've barely scratched the surface of what Java 7 is. So until now, I've talked about specification, but at the end of the day, if you want to write code, you need an implementation. Today, the only implementation of Java available on the market is Glassfish 4, which is the open source reference implementation of Java 7. It's available since mid-June. So it's the world's first Java application server, but Java 7 application server, sorry. But we hope and we expect to have more on the market. I mean, if you look at JBoss, so Wildfly, it should be available within a few weeks from now. And we just think that well, it's just the beginning. Others will follow. One easy way to start is to download the bundle of Glassfish and NetBeans. So you just install NetBeans. It has all the Java 7 wizards, and it has Glassfish installed by default. So this is Java 7. So here are some ideas that we are thinking about what could make sense for Java 8 and beyond. Now, it's just some idea, and we have to keep in mind that everything has to be done through the GCP. So again, keep in mind the first slide disclaimer. So what could make sense for the future of Java E? JCache. So basically JCache is to cache what JDBC is to database, an API that allows you to plug easily any cache provider, such as Coherence or EHCache. We've tried to put it in Java 7, we couldn't, so it makes sense to continue to work on that. JSON binding, also, until now we have streaming and processing, but binding is certainly something that would be useful. working on configuration. I mean, solving some of the DevOps issue that are out there. Maybe that's something also we need to work on for Java EE going forward. State management, NoSQL. NoSQL is a big one because clearly there is a strong push for the market for NoSQL, but there is no real standard for NoSQL, so it's kind of difficult to exactly know what we have to do. So if you have ID, just shout. And we are clearly listening at that feedback. Cloud is also obviously something which is quite important, so something that has to be addressed as well in the future of Java EE. Continue to work on the HTML5 support. So maybe we could do more. So that are some of the things we are thinking for Java EE 8 and beyond. Obviously, this is the early days. So if you have ID, feel free to reach to us, feel free to reach to the Java EE expert groups. And I mean, if you have ID that are valuable, we will obviously listen to them. So I want to spend my last 5 minutes on Java EE and innovations. So I've talked about Java EE. We have looked at what Java EE 7 is. So it's basically all specifications. We will have implementation. Glassfish is one of them. Wildfly will be another one, and we expect the others, such as WebLogic and WebSphere, to follow. So the fact that all these application servers are implementing the same specification leaves us a lot of room for innovations. Because if all the implementers, so Oracle, Red Hat, and so on, would just implement the specification and nothing else, well, we would basically have 20 times the same product. So we really have to innovate next to the specification, and that's what we are doing. A good example is WebLogic. So WebLogic is another application server. It's fully compliant to the Java EE specifications, but we are putting a lot of innovation in WebLogic to make sure that it stands out. For example, the specific optimization we are doing for our engineer systems, those kind of things. The support we are providing for the database, so the DB12C. Those kind of things are really innovation that brings unique features to an implementation, in this case to WebLogic 12C. So there is a lot of room for innovation within the Java EE context. Something else I want to quickly touch on is the Internet of Things. So if you look today, well, we all have mobile phones, so it basically means that we are connected all the times on the network. Now, very soon we'll have a smartwatch, so another device that will be connected on the network. If you look at the new cars, most of the middle-class cars are connected on the network by default, and so on. So there is a clear tendency, there is a clear trend that's more and more we are putting devices, and those devices are connected on a network. And basically the fact that those devices are connected on the network will provide some kind of values. Now, there is also, well, Java EE has also a role to play in that field. I mean, it's nice to have a lot of devices on the network, but those devices are spitting data. So maybe we can use Java EE to get those data, filter them, and process them, and then send them to the backend. So Java EE doesn't have necessarily to be just on the backend side. We can also put Java EE more deeper on the network, so closer to the device. That's what we are doing with the Java Embedded Suite. So it's basically a virtual machine. So Java SE embedded, Glassfish with JAX-RS capabilities, and a lightweight database. So that's something that you can put on the network, deeper in the network, closer to the device. And the message I want to pass here is that you don't have necessarily to think of Java EE as being the standard for backend side. Yes, it is the standard for backend side, but you can also use Java EE somewhere else, in the network, for example. That also means that there are new opportunities for you. You can use your existing Java EE skills today for new applications, new opportunity. So that's something you have to keep in mind. And clearly, the Internet of Things trends is something that will get us there. And finally, something else around innovations and Java EE is Project Avatar. So clearly, Project Avatar is not part of the Java EE specification. So don't look at this as being something which is Java EE. That's something we run on top of Java EE. What it is? Well, it's what we call a TSA, so a Team Server Architecture. So the idea is that we are using different things. So the first one, we are using avatar.js. So avatar.js is basically a node implementation running on top of the Java virtual machine. So nodes.js by default is JavaScript based. Now you can use JavaScript on top of the virtual machine because we have Nashorn. Nashorn is a JavaScript interpreter that will come in Java SE 8. So we are using Nashorn to provide node capabilities on top of the Java platform. So that means that we can reuse the nice features we have provided by the platform itself. So we are using that. So that means that we are pushing more, I would say, the presentation layer on the client side. So the presentation layer runs on the client side. And the backend side is used as a team server to deliver that layer to the client side, but also provide through WebSocket or RESTful Web Services, data services. So for example, those kind of things. And you will have the client that will use that. So the avatar is now open source. It's available under avatar.java.net. And so it's an open source project that we are using to kind of see what would make sense going forward. So should Java EE move to a model which is closer to that? We don't know, but we want at least to give the ability to test that. So it's another way to show that there are ways to innovate around Java EE. So the call to action to conclude, well, it's time to look at Java EE seriously. It has been launched, it has been released. You saw some of the benefit of Java EE. So an easy way to get started is you can download the Java EE 7 SDK. It has a tutorial. The tutorial is roughly 1,000 pages that is going over all the specifications to help you to quickly start with that. And it has also Glassfish 4, the Java EE reference implementation, the Java EE 7 reference implementation. So it's open source, it's free, so I really encourage you to download that today. So with that, I'm just in time, so I would like to thank you for having this opportunity. Thank you. Okay, so we have 5 minutes of questions. So is there any questions on Java EE? Yes?
Yeah.
Please. No.
Thank you for a very interesting presentation. What I wanted to ask, most of things like we were talking about JMS, for instance, they're currently covered by Spring.
Sorry?
And most of boilerplate things you are actually explaining, they are currently covered by Spring. I mean,
yeah. So the question is around Spring and Java EE. So
I'm sorry, I'd like to put it like Spring versus Java EE. Like we have servlet IP, new servlet IP, but most of people use Spring on top of servlet IP, and they only need to inject the dispatcher, and then everything goes to Spring and works there. So how are you going to deal with that? How are you going to integrate?
Well, it's not really our job to integrate with Spring. I mean, but so what is clear? I mean, Spring is also moving towards Java EE 7. I mean, Spring will not be fully compliant to Java EE 7, but they said that, for example, they will adopt so the batch API will be part of Spring, so they will comply to that one. The WebSocket API, they will be also compliant to that one, and so on. So yeah, I mean, there are different options on the market. Spring is one of them, and I think we can thank Spring because in the early days, when in the G2E14 time frames, it's really those kind of frameworks. I mean, Spring was a big driver to simplify Java EE. So that's why we had ease of development in Java EE 5 and so on. And yeah, I mean, if you are a Spring user and if you're happy to stay with Spring, that's fine. But we don't have to integrate with Spring. I mean, if Spring wants to work on top of a Java 7 application server, well, maybe they have to do some things on their side. But that we don't want to put things in the specification to say, okay, the Java specification needs to, you need to do that if you want to integrate with Spring.
Okay, and the last one question.
Yes, there is one last one.
Okay, thank you for the great talk. Can you answer about how many lightweight application, serverless containers have already implemented in the new lightweight transaction API? Thanks.
I would say that so the Java transaction API is part of Java 7. So I would say that any Java 7 compliant application server needs to implement that API. Today it's just Glassfish, but as I say, Wildfly, so the open source version of JBoss, they are feature complete in terms of Java 7, and they are stabilizing that. And I guess that by Devox, so mid-November, they will have their first Java 7 release. So in November, we will have a second Java 7 application server that implement that API. And that will only continue. What about? What about, sorry? JT? Okay, Apache Tomcat, so there is the TomEE application server, which is not yet compliant to Java 7 as far, no, it's not. I think, but yeah, I mean, as soon as TomEE is compliant to Java 7, now we have to look if GDA is part of the web profile, because TomEE is only web profile, so yeah.
Okay, thank you, David, for his presentation.